Hey everybody, just a couple of quick things here. I've got some questions that I need to answer, and any questions you guys have, please email those to me. I will kind of do a Q&A at the start of each session here, I guess. First one is Pi Day projects. When will those be graded? Great question. I have no idea. I'm not allowed to go back to school. The only time I can get in there is if I'm picking up something real quick and someone's there to open the door. So they haven't been graded yet. They probably will not be graded until we go back to school. So there's that. Also, several people said that the text that I was showing you guys on the computer screen was difficult to read. You're right, it was almost impossible. And so what I did is I uploaded that document on the Sway page. You guys can go ahead and take a look at it. One's titled High School Grading Plan, and another one is titled AP Exam Update. And so the calculus students are the ones that want to look at the AP information. I will use better settings from now on so that anything I show you guys, it'll be a lot easier to read. I was just trying to save some memory, and it didn't work very well. So we'll just have bigger files. One comment I want to make about a question that I've been asked, and also about the high school grading plan, is people have asked me, like, is this going to be graded? Do we really have to do it? The answer is yes. The expectation is that every kid in Tacoma School District, whether you're in kindergarten or a senior ready to graduate, is working on something. You know, we as teachers are trying to provide you guys with something, so we don't just waste 6 weeks worth of time. So no, it's not going to be graded, but yes, the expectation is that everybody does the work. So please do so. You know, I think if you choose not to, you're just hurting yourself, and that's not a good thing. We're trying to make the best out of a difficult situation, and you know, we all know this is unheard of. Never happened before. As far as the AP exam goes for calculus students, the AP exam is on, but it's my understanding it's a lot shorter. It's going to be an online test. It's going to be 45 minutes instead of 3 hours. And there's a lot of information that you guys need to read. I put that document AP exam on there. There's a link you want to click on, and then you can go ahead and read and see what it's talking about. Hey everybody. Yeah, I thought I'd wear a polo today. I realized I didn't have one on last time, and I'm sure it was awkward for all of you. So hey, we're gonna, like I said before, we're gonna jump ahead to chapter 7, and the item that we want to start with in this chapter is trying to find the area between two different curves. Let me show you what that looks like. All right, so we're trying to find the area between two curves, and what that means is, let's just say I've got an XY axis here, and here's some kind of cubic equation. And let's say here's a parabola. And what I want to do is I want to find the area between those two curves. Well, it's not as hard as it looks. Let me change this just a little bit, and let's say I've got an upside down parabola, and instead of a curve, let's just say I've got a linear function, and what I'm looking for is the area between those two. Well, I know how to find the area underneath the parabola all the way down to the x-axis. I just don't want the area that's underneath the linear function. And so if you think about that, well, first of all, let's just say that these two things intersect at point A, and they also intersect right here at, I shouldn't say point, it's an x value, and also they intersect at an x value of b. So really, to find the area between these two functions, I want to look at the interval from a to b. And I know that if I did the integral from a to b, let's call the parabola f of x, and we'll call the linear function g of x. If I did the integral from a to b of f of x dx, that would give me the area underneath the parabola, but it would include all of this area right here as well. Well, I don't really want that area, right? So I need to say, let's subtract the integral from a to b of g of x dx. And I don't know if you guys remember this, but we had something that said you could separate two integrals. Well, you can also put two integrals back together if you want, as long as your limits are the same. They both go from a to b, and so I could just write this as one integral from a to b of f of x minus g of x dx. And this right here is our formula for the area between two curves. That's what we want to take a look at for today. Let's back up to the first picture here. If you think about this, would that same situation work for this? Because part of this curve is below the x-axis, which means we're going to get negative area down here. Well, what I want is the area underneath the cubic function down to the x-axis, which would all be positive area, minus this area down here, except this area is going to be negative. So when you subtract a negative, you end up adding that area. And when you think about it, that's what you really want. I want all this area up here plus this area down here. And so this method would work for that situation as well. A lot of times people think of this as the integral from a to b of the top curve minus the bottom curve dx. And when we say top, we just mean the one that has the higher y values. The bottom curve is the one that has the lower y values. And so here the cubic would be the top curve, the parabola would be the bottom curve. And that's how you find the area between two curves. Let's do some examples. All right. So first example, I want to find the area between f of x equals 3x squared plus 2x and g of x equals 8. Now at this point I don't know which curve is the top curve and which curve is the bottom curve. I won't really know that until we graph them. I do know that if I graph y equals 8, that's just a line up here at 8 that goes straight across my graph and perpendicular to the y-axis. So that's g of x equals 8. For the parabola, well, let's see. If I factor an x out of each of those, I would have 3x plus 2. And so my zeros would be at x equals 0 and a negative 3/2. I'm sorry, negative 2/3. So I know that this parabola is going to cross the x-axis here. And let's just say that this is negative 1. Say this is positive 1 over here. It's going to cross at a negative 2/3, which is right about here. So my parabola will look something like that. So what I really need to know now is, where do these two graphs intersect? And so to figure that out, you just set the two equations equal to each other. 3x squared plus 2x equals 8. Bring that 8 over, so we set the whole thing equal to 0. And then I want to see if I could factor this. So this could only be 3x times x. Let's see, if I call this 2 times 4, and I put a 2 here and a 4 there, that would be 6x and 4x. I could subtract those to get a positive 2. So I'll make this positive and this negative. Positive 6x minus 4x, that would equal a positive 2x. So my points of intersection are at x equals 4/3 and negative 2. And so what that means is I want to do the integral from negative 2 to 4/3 of top curve, which is g of x, that's just 8, minus the bottom curve, which is the parabola. And I got to put this in parentheses so that I make sure I subtract the whole thing. And now we just need to solve that integral. You guys go ahead and take it from there. Now, when I say that, you guys go ahead and try something. What you want to do is hit the pause button on your computer. I'm just going to wait for about 5 seconds, then I'll start doing the work. But if you hit the pause button, that way I won't start until you get the video going again. Okay, go ahead and give it a shot. I grabbed another whiteboard because I think I might need a little extra space. So I think to solve this integral from negative 2 to 4/3, I'm going to first of all just rearrange these terms. I'll start with a negative 3x squared minus 2x and then plus 8. So I want to add 1 to the exponent and divide by the new exponent. So this will become a negative 3x cubed over 3. 3's will cancel, so I really just get a negative x cubed. This will be a negative 2x squared over 2. 2's will cancel, so a negative x squared plus 8x, and then I'm going to evaluate that from a negative 2 to 4/3. So I'll put in 4/3 first. When I cube that, 4 cubed would be 64. 3 cubed would be 27, and that would be negative. I'll put 4/3 in here and square it, so I'll get minus 16/9. And when I put that in here, 8 times 4 would be 32, so I get plus 32/3. And now I got to subtract whatever I get when I put the lower number in. So if I put a negative 2 in here, negative 2 cubed would be a negative 8. And then the negative of that would be a positive 8. Put a negative 2 in here and square it, you get 4. And we're subtracting that. And put a negative 2 here and you get minus 16. And I think at this point, I'll just go ahead and punch that whole thing into the calculator. I don't have our TI-89 with me right now. I do have one in the other room, but I'll just do this on the TI-84. So in parentheses, I've got a negative 64 divided by 27 minus 16 divided by 9 plus 32 divided by 3. We'll close parenthesis and then subtract what I get over here. That's going to be 8 minus 4, that's 4. 4 minus 16, that's a negative 12. So I'll just put a negative 12 inside parentheses. And there's my final answer. 18.519 square units, because we're talking about area between two curves. Now, if I wanted to, I could go ahead and change this back to a fraction And there would be the exact answer. So 500 over 27 square units. All right, let me give you guys one to try on your own. All right, so here's what we have. F of x equals 1/2 x minus 1, and g of x equals 3 minus x squared. So first thing we have to do is we have to graph this, decide which graph is the one that's on top, has the higher y values. We also have to figure out where that point of intersection is. So you guys go ahead and try that. Find the point of intersection, set up your integral, and find the area between the two curves. So if you didn't get very far, maybe you didn't find the final answer, remember, once I start, you can always hit the pause button and go, oh, now I know what to do, and then continue on your own. That's the great thing about this. You can pause it, rewind it, do whatever you want. Okay? So first I'm going to find the points of intersection. So I'm going to set these two things equal to each other. 1/2 x minus 1 equals 3 minus x squared. So I don't really like fractions, so what I'm going to do is I'm going to multiply everything by 2. And so what I'll get is x minus 2 equals 6 minus 2x squared. Now I want to set the whole thing equal to 0, and I really want the x squared term to be positive, so I'm going to move everything over to the left side. So I'm going to have 2x squared plus x. When I move this 6 over and subtract it, I'm going to get minus 8, and that's equal to 0. And so now I'll try and factor this. I've got 2x times x. Oh, great. Looks like this might be something where we have to use a quadratic formula. I could do 2 times 4, but that's not going to give me 1. 8 times 1. Yeah, I don't think this is going to work. So I have to use the quadratic formula. So x is going to equal a negative b plus or minus the square root of b squared, which is 1, minus 4 times ac. A times c is a negative 16, all over 2a, which will be 4. And so that's going to be a negative 1 plus or minus the square root of, let's see, this will be a positive 64 plus 1, that would be 65, all over 4. So what we're going to do is we're going to get decimal numbers for that. So take my calculator. In the numerator, I've got a negative 1 plus the square root of 65. Oops. Close parenthesis and then divide that by 4. So I've got 1.766. Now, I'm going to want to remember this number, so I'm going to store this in memory. And we can do this on our TID9s as well. So I'm going to hit store alpha A. I don't know if that's really the first number I'm going to get. Actually, this is, when I do negative 1 minus the square root of 65, that should be my A value, because that'll be negative, this is positive. I'll call this B. So I'm going to store this in alpha B. Okay? Store in B. Or, my other answer is going to be I just need to change this to a negative. There it is. I get a negative 2.266. And I'm going to store that in A. So store alpha A. All right, so now when I evaluate this, I've got my exact values to work with. All right, now we need to graph these so I can see which graph is on top and which is on the bottom. So let me just draw a graph right here. Let's see. This is an upside down parabola that's been shifted up 3 units. So there's that parabola. This function, if I think y equals mx plus b, I've got a y-intercept of -1 and a slope of 1/2. So I'll go up 1 and over 2. All I know is that the line is going to go something like this. So these intersect right here at -2.266, and they intersect over here at 1.766. From the graph, I just really need to know which one's the top curve and which is the bottom curve. Now I could set up my integral. So my integral is going to go from a -2.266 to 1.766. I want top curve minus bottom curve. So I want the parabola minus the line. So I've got 3 minus x squared minus this line, which is going to be 1/2 x minus 1. Remember, put each of these in parentheses so that if you have to distribute something, it gets distributed to each term. Now we just need to solve that integral.